Tyler scooted over to that one, the other two.
Actually, kind of like to see that. Yeah, I asked her about this in like 5th grade. We've got, what, 5 people in there now?
Yeah. Look at her count those squares like you do.
I think we can. Oh, that's nice.
Alright, while you're finishing writing that down, just to give you a little preview of what we're gonna do this week, we're gonna spend today mainly just taking notes over these 2 new forms, cause that first form up there we covered last week, standard form, right? So I got 2 new forms up there, Vertex and Intercept, so we're gonna take some notes over that today. And then maybe tomorrow do some practice together on it, and then Wednesday on your virtual day, do something, assignment. And then Thursday, we're gonna start learning how to solve quadratics, which is the fun, I like the most. It's where we'll get into a lot of different types of solving and all that. So really just have 2 new days of information and then spend the rest of the week practicing on those, what we learned, the new stuff. On that Vertex form, if, I know that's hard to read, these are H and K, H and K. And then on the Intercept form, it's P's and Q's, okay?
What's that, squiggly thing on the intercept form? M2P.
Minus
Are they?
signs?
Oh, are they parentheses?
Yeah, X minus
Okay.
P's in the parentheses and X minus Q's in the parentheses.
Okay, it looked like little like squiggly thing.
Yeah, we'll see where it is. finishing up some of us there, but go ahead and start talking about this. Standard form, you know when you were in Algebra 1 and you graph lines, you have the standard form of a line. Every function that we do has one that's called standard form. I don't really like that because it doesn't really tell us anything right off the bat, but we learned we can use the axis of symmetry formula to get started. These other two tell us what their names are. So vertex form, guess what? We can get the vertex straight from it. If it's in vertex form, you don't have to do any math. We're going to learn how to just pull the vertex form straight from it. The first, your axis of symmetry, the first part of the vertex is what's in that spot. Okay, now notice that has a minus sign in front of it and this doesn't. So that means you'll make it the opposite sign, okay? So if this were x minus 3, you would put a 3 here, okay? The plus k, it just is what it is. So if this said x minus 3 plus 2, 2 would be your vertex. You didn't even have to do any math, okay? Intercept form tells you what the intercepts are. Now you already know what the vertex looks like. It's the center of that parabola, either the min or the max, that's where that is. Intercepts mean where it crosses the x-axis, and we'll look at that in a minute, but those would be where it crosses the x-axis. So this thing here is to find the axis of symmetry. You just add your p's and your q's and half them, because the axis of symmetry's got to be in the middle, half, right? So you half them. Now same thing with the h up there. Notice this says x minus p, but it's a positive p. X minus q, but it's positive q. That means you make it the opposite sign. Okay, we're going to work some. I'm not just leaving you on that, but those are the things to keep in your brains. All right. Let's get this thing rocking and rolling. Already turned it on. New page. Hopefully it's not still a white marker. Good. All right, so I've got y equals negative 1/4 times x plus 2 squared plus 5. Thunder. All right, so you have right there in your notes from off of the bell ringer board, you have the 3 forms of the quadratic. So go down the list. Does this one look like standard form?
No.
Nowhere in standard form is there parentheses, right? So it doesn't look like that. Does this look like vertex form?
Yes.
Yes, we got one parentheses being squared. So we're in vertex form. So if we're in vertex form, it's telling us what the vertex is. So remember, your vertex is the h comma k, but the h, the one that goes first, has the opposite sign. So we have a positive 2 where that h is. So what are we going to put over here?
Negative.
Negative 2. And then the k, the last part of the vertex, is what's stuck on the end, and it keeps the correct sign. So we got a positive 5 there, so we put a positive 5 there. Remember, in standard form, we had to use our axis of symmetry formula, then we had to plug that back in and solve again. We didn't have to do anything. Easy schmeezy, that's some good stuff. So let's look what that would look like on the graph. I would go left 2 and up 5. So there's my vertex. That would also be where your dotted line is for those of us that are drawing our dotted lines. Okay, now I'm going to tell you, and you're going to know because that's how smart y'all already are. Is this thing going to open, is it going to be a normal one that makes a big U up here? Or is it going to be an upside down one that makes a big N down here? And you know enough to know. Good, good, good. It's an upside down. Remember from standard form we were upside down when our A was negative? In vertex form, this is your A, what's out in front. So we've got a negative A here. So it's going to be going down. But we still need to find another point. And when we find the other point here, we do it the same way as we did in standard form. We just pick an X and plug it in and solve. Okay, so do y'all got an X you want to plug in and solve with? Okay, zeros are not as easy here, but I still would be with Tyler and plug that 0 in. Let's see if we can figure this out here. 0 plus 2 is 2. Then we got to go to exponents next, so 2 squared is 4. So then I multiply, so I'm now looking at negative 1/4 times 4, and then plus 5. Okay, if you don't know negative 1/4 times 4, you can type that in your calculator. But I think if you use some common sense, you do know that. Because if you've got 4 and you're splitting it into fourths, how many does everybody get? 1, and it's negative, so it'll be negative 1. Negative 1 plus 5. So we get the 0.04. So I'm going to go over 0 and up 4. Okay, now remember, I could pick another one, like over here where we did that. I could do it again, but it'd be faster, like Christian said, just to flip it to the other side of the dotted line. So that is 1, 2 away from that dotted line. So I'm going to go 1, 2 away on the other side. It got into my work there, but y'all can follow that. Oh, I missed bad on that one. There we go. A little better. Okay. Now, like we talked about on the standard form ones, I think if you, those y'all that like to graph in your calculator, I think these are even easier to graph in your calculator because you know what the vertex is. So you can just pull your vertex out and then plug that into the y equals on your calculator and get those other points without having to do any math. You know, before, some of them, like those ugly fraction ones that we were working on Friday, we still had to do the x equals to find the vertex, but you won't have to do that now. It tells you the vertex if it's in vertex form. So I did 0 plus 2 is 2. So I didn't write all my steps. Let me get you caught up to my steps. 0 plus 2 is 2. 2 squared is 4. So that's where I picked it up at. I should have put those other 2 on there. Let's go forwards. There we go. All right. I got f of x, which that's the same as y. Just want you to get used to seeing it written both ways. F of x equals 1/2 times x minus 3 squared minus 5. I'm going to be quiet for a minute and see how far you get, just like we did on the last one. See if you can label the vertex and the axis of symmetry and graph it. What'd you come up with for the vertex? 3, -5. That's exactly correct. Great job. Anybody not sure about that? Opposite sign here. is what it is on the end. 2 thumbs up, great job. So I'm gonna go left 3 and down 5. I said that backwards, I said it wrong. I'm gonna go, that's a positive 3. I'm gonna go right 3 and down 5. So it's gonna be down here. 1, 2, 3. So there's your dotted line. Okay, now I need another point. Well, before I get my other point, have I put myself in a tight spot? I'd be in a tight spot if this thing was gonna open down, I didn't save very much room. Is it gonna open down and I'm in a tight spot, or is it gonna open up and I'm good to go?
It's opening up.
It's opening up because my 1/2 is positive. A is positive, so I'm good to go. So what X do you wanna plug in? 1, gonna plug a 1 in this time, I like it. 1 minus 3, I wanna show all my steps this time. Okay, 1 minus 3, that gets me a -2. So then I've got 1/2 times -2 squared minus 5. Then I would square -2. -2 times -2 is 4. So I got 1/2 times 4 minus 5. 1/2 of 4 is 2. So I got 2 minus 5. So -3. So I'm gonna go right 1, down 3, Shazam. Okay, now that is 1, 2 away from the axis of symmetry. So I'm gonna go 1, 2 away on the other side. That is a fabulous looking parabola. Have you noticed yet, and I think we talked about it one day last week, but have you noticed yet what makes them be fatter or skinnier? If I remember?
Isn't it the X? I mean, no, not the X, the A.
Uh-huh. So the smaller, the closer our A gets to 0, the fatter our parabola gets. So when you have a fraction out here like this, less than 1, it makes it wider. But if you got a big, like if this had been a 2 or a 4, that's when it gets more narrow, skinnier. Cool, cool. You feel all right with Vertex Form, or you want to do another one? I mean, we will do more throughout the week, but you want to go on to Intercept right now, or? All right, we will. We will. Okay, you're growing. Got the hiccups, you're growing. That's what my granny used to say. Of course, she was not even 5 feet tall. She didn't have hiccups very often, I guess. Okay, so since this is our first one in Intercept Form, let's pretend like I didn't tell you that, and let's go down and figure out how we know it's an Intercept Form. Standard form doesn't have any parentheses in it, right? The next is Vertex Form. Vertex Form has 1 parentheses that's squared. We don't have that. So the last one is Vertex Form. The last one is Intercept Form. Intercept Form has 2 parentheses. So good guess that this is Intercept Form. So what does Intercept Form tell you? It tells you your intercepts. And I was hinting to this earlier, but I didn't want to mess up my bell ringer page and draw it. Intercepts on this graph is where we cross that axis. So that's what we're looking at, the place that crosses that axis. So if it crosses, if it's on the x-axis, it doesn't go up or down any. That's why they were both comma 0, because you don't go up or down any. Okay, so our first intercept, opposite sign here, so what's it going to be? -3, very good. Our second intercept, opposite sign here, what's it going to be? 1. So if I plot both of those now, this first one I would go left 3 and up 0. Second one I would go right 1 and up 0. Alright, so what we got to think about now, that what this could be, we got 2 choices. This could be a parabola that goes, y'all follow my finger, parabola that goes like this, and hits both of those points, or it could be a parabola that goes like this and hits both of those points. Okay, y'all are nodding your head good. It should go up. And the reason it should go up, this is still your A, and our A is positive. So it's going to go like this, which means it's got a minimum down here somewhere, right? So there's a couple of ways for us to find out that minimum where the vertex is. On your note, your bell ringer page, I gave you a formula. When you got nice, pretty whole numbers like this, it's easy just to use common sense and count. Because the vertex has to be in the middle of those 2 points, right? We got to be able to draw a dotted line halfway between here so that those points land on each other. So you could just say 1, bam, there it is, right? But sometimes they're ugly fractions and it's not that easy to tell. So I told you to take your P, which that's in your not, use this one, the one with the opposite sign. You take your P, you add that to your Q, and you half it. So on the top, -3 plus 1 is -2. Half of -2 is -1. And that's exactly where we saw it when we used the common sense and counted. Okay, so that's your fold line, but that doesn't tell you the minimum value. So this formula, even though it was nice and it gave you 2 points, it left you a little more work to do to get the big one. So we know we're at -1. What do we do to find out how high or how low that is?
Fill it in.
Just plug it back in. Very good. And we got 2 x's to plug it in for. So our y is going to equal 2 times -1 plus 3 times -1 minus 1. Okay. So in my parentheses first, in the order of operations, -1 plus 3 is 2. And -1 minus 1 is -2. So now I've just got multiplication, so I'll go left to right. 2 times 2 is 4, times 2 is -8. And that makes sense because we said it was going to open up, so it needed to be down lower, so I'm going to go left 1 and down 8. Put that over there on the dotted line, and there you have your beautimus. Whoa, that was bad. I'm going to erase that. I didn't get anywhere close.
When you plug in the X, the P and Q,
Uh-huh.
do you take the opposite side?
I'm not sure. Hold on, let me understand what you're asking. When I plug it in where?
So like you took the P and Q and you did like the
Here?
3, what?
Or where are?
Read it?
When you
Show me
took
on
the
your
P and Q,
Mhm.
when you did that one.
We take these signs from the vertex.
Oh.
Gotcha. What he was asking about was when we did the work to get the axis of symmetry over here on the far right, you use the P and the Q, the opposite signs from the vertex. Okay? Now, so I could have, if I'm a calculator user, and if you are, that's fabulous, I could have got this without doing that math. Because I could have, again, just went to the y equals and plugged that in. And it was not very hard for me to figure out where my axis of symmetry is. So I could go to my table. Remember, we talked about going to our table. Find where x is -1, and it would say -8 for you.
What if it would have been a fraction?
If it had been a fraction, you had to have done that. There is a way to change the settings in those calculators to show, but I don't know enough about it to do it. I'd screw it up and we'd probably start calling Japan or something. I don't know. All right, let me let you practice on one of those. Fabuloso. Let's look at y equals 3 times x minus 4 times x plus 5. All right, I'm gonna be quiet and let you do that. And then we got just a couple more things to look at. so the first, I'm making a big assumption here, and this is where it's gonna be a dilemma whenever we start looking at all the different forms together. You gotta be able to make sure you can identify which form it's in, but I'm making the assumption for this one that you realize we're still in intercept form, so I've got this set up ready for your intercepts. But you make sure you're able to differentiate there. Okay, so what's my first intercept gonna be?
4, 0.
4, 0, opposite sign there, very good. What's my second intercept gonna be? Negative 5, 0, so this one, these intercepts are spread a pretty good distance apart, aren't they? That's 9 apart, I know that. 1, 2, 3, 4. Negative 1, 2, 3, 4, 5. Now, halves are not difficult to deal with, but every student I have today is not gonna be able to use common sense on this, because if we started counting, 1, 2, 3, so it's gotta be halfway between those. And you would have known that, I'm gonna do it using the formula. You would have known that though, because if you think about adding those, you get an odd number, don't you? And when you half an odd number, that's where the half comes in. But let's look at it on our formula. It said we do our P plus our Q, and we divide that by 2. So 4 plus negative 5 is negative 1, and we divide that by 2. So our dotted line is gonna be halfway between 0 and negative 1. Which is where I just showed you, y'all, because y'all are pretty sharp, y'all could have found that doing the counting. But I'd have some people that would struggle and they just pick a whole number and put it on it. It's not supposed to be a whole number. Now that's gonna make our finding the min or the max more difficult, because when we plug it in, we got a fraction we gotta plug in. Do you think is it gonna be a min or a max?
Min.
Very good, it's gonna be a min, because it's gonna open up. I'm betting my boots that it's gonna be way down low. I'm probably gonna have to draw something way down here, because those things are far apart. Okay, let's plug in our negative half and see. Alright, in my parentheses, I already owe, this is how my mind works on negatives. Half is, I'm gonna say, is like $1.50, negative, so I already owe you 50 cents, and now I borrow 4 more. So I owe you negative 4.50. Put a 5 because I said 50. My brain can't multiply fast. Over here, I already owe you 50 cents, but I find $5. So now I only owe you $4.50. Okay. So I got 3 times negative 4.5. What is that? Can somebody help me? Here I got to do the fraction. Negative 4.5. 27 halves. And then I gotta multiply that by another 9 halves. So that's gonna be 27 times 9 is 18.
27.
243. Okay, so now if I put, because I don't have any idea what that number means on my graph. So now let's make that either an improper fraction or a decimal. I mean a mixed number or a decimal. That'd be 6 3/4. Anybody? Well, no, I'm just trying to do some fractions in my head. I thought y'all, yeah, I got that. I got the, but it'd be negative, so I got the negative 27 halves. See, this is why y'all have calculators to help me with these fractions. So if y'all just typed it all in, which is what I would have thought y'all would have done, let's hit, I'm gonna go back to right this line, this first red line, where we first plugged in the negative 1/2, and I'm gonna type that in. Do you need me to get my, let me get my calculator up there on the screen so you can see.
I just forgot that it was a negative half. Yeah. Got negative 57.75. And I already drew it.
Alright, so, this nonsense going. Alright, I know we had a, this is what happened last week, wasn't it? I know we had a 3, and then -1/2. So I'm gonna, can I 0.5, that'll make this go quicker, is that okay? -0.5, then what was in that first parentheses? -4. Close that. -0.5 plus 5.
Yes.
So that's all you would have to type in on your calculator to get around all that fraction work I was working. So I hit enter.
I didn't think that could be
60
right when I
and
got it.
3/4. Well, I said it's gonna have to be way down there. I just didn't know how way down there it's going to be. -60 and 3/4. So we're fixing to estimate that.
I forgot what number I was
So on this dotted line, we gotta go down 60 and 3/4. You wanna know where that is? It's right here. Now, if this were on an assignment or something, we had to show, we found the vertex, we found this was -1/2, -60 and 3/4. So we're gonna put that, we're labeling it, we know what it is. We just don't have the capability to count down 60 on our paper and make it still say on the paper. I guess I got some of that big poster board paper, we could roll that out across the floor.
Did you write down -67/4?
3/4.
Oh.
Was that what it was?
Just kind of looked at it.
Y'all are gonna figure out how bad my handwriting is. I'm an old woman and my dad still yells at me about my handwriting. Get over it, grumpy old man.
TC's handwriting is
Yeah,
terrible.
his is. Okay, so the last couple of things I wanna look at, turn that off, is going from one form to the other. Like if I give you one form, converting it to the other, it's not very difficult, we'll look at it. Let's say I have y equals -2 times x plus 5 times x minus 8. Okay, so first, the directions say to write it in standard form. So here's my first question for you. What form is that in now?
Intercept.
Very good, it's an intercept. So we've got intercept form and they want us to write it in standard form. So we gotta remember that standard form takes those parentheses out. We just get an A, B, and a C when we're in standard form. So what could I do to my intercept form to start getting rid of those parentheses? Very good, I'm gonna multiply. Now you've got some options. You could take this -2 and multiply it first, but I would not. I would look at that hunk first, multiply your two binomials, so then your last step would be just to distribute a -2 to all of it.
Where did we get that?
Well, good question, Christian's asking about where's the exponent gonna come from? Can anybody tell him, where is the exponent gonna come from?
Oh, the X.
Very good, right there, you're gonna have x times x, and that's where your x squared comes from. Then I'm gonna multiply that x over here, gets me a -8x. This is stuff you did in Algebra 1 that we're looking at now. I'm gonna take the 5 now times the x. Remember last week I called this FOIL, or you can say distribute. And then the 5 times the -8. Now I could distribute that -2 now, but there's one thing that will make it simpler that I need to do first. Very good. So I got x squared minus 3x, because -8 plus 5, minus 40. So what we've done, we're trying to write it in standard form and we're almost there. We've multiplied all that. Now I need to multiply all of it by -2. So I'm gonna drop a parentheses and a -2. Remember, this is still y equals, I didn't show that very well. So I'm just gonna start distributing that -2. So I get a -2x squared. A negative times a negative will make that a plus 6x. And then a negative times a negative, 2 times 40 will make that a plus 80. Bada bing, bada boom. Now, I don't know why you would want to do that, other than your test tells you to. Because I think if I'd have left it up there, I could have graphed it faster. But you might have a question on your test that tells you to do that, so I wanted to do it. I want to use the other one now. That was Intercept, so I want to let you get that, and then we'll use the Vertex Form. Everybody good there? Y'all done fabulous today. Last one, and you'll have a little bit of easy time at the end today. I've got f of x equals 4 times x minus 1 squared plus 9. And the directions are the same. It says to write it in standard form, so y or f of x, they're the same. We want it to be y equals ax squared plus bx plus c. Okay, now this one is assuming that we remember something pretty important, and I haven't talked to you about that yet. I gotta know what to do when I have a binomial that's being squared. Does anybody remember? You haven't, I mean, algebra 1 was a long time ago, I know.
You square each one
No, and that's what almost everybody will try to do. So that's the common thing. What Tyler's talking about is I see this every single year. People will say, well, just square the x and square the -1. But that won't work. You know why not? I mean, you know, another guess? That squared is outside that whole parentheses. So that means we have to write that whole parentheses twice. Okay? And you think, well, it's still going to be what Tyler said, but it's not. There's going to be, it'll end up being something that's just an x to the first in it when we do this way. So let's go ahead and do that. Let's get our x times our x. My x times my -1 is -1x. You can put a 1 or you don't have to. Same thing here. My -1 times x is -1x. And then I got a -1 times a -1. Now, just like on the last problem, we're going to combine those. So a -1x and a -1x is a -2x. Alright, so what we haven't touched yet from the original function. We got a 4 and we got a plus 9. Which one do you think, that 4 means multiply, which one do you think we need to do first? Good, why Christian, do you think that?
Because it's connected.
Right, and if you think back to middle school, order of operations, multiply comes before add, doesn't it? So let's go here and distribute that 4. 4x squared minus 8x plus 4. And then the very last step, now I'm going to drop that 9, bring him down to the party, and I got a plus 9 stuck on the end. So that plus 9 only has one like term to combine with. So for our final answer, we've got 4x squared minus 8x plus 13. And again, that's not something I'm going to ask you to do a whole lot of, but it's something you should be able to do. Okay, nothing real hard on that. So what I've got planned for us tomorrow is going to go back to more of the graphs. I'm going to have you graphing some of those from Vertex Form and from Intercept Form, which we learned today, so it won't be that big of a deal, that hard for you to pick up on. And then on our virtual day, I haven't made the assignment yet for virtual day, but it'll be the same type of stuff that we do tomorrow. Okay? Everybody good today? Pretty easy? You feel good about it? Good, Zach? Zach, leave me alone. Gotcha. All right. So I'm cutting y'all some. Let me push stop first before I say it.